All right, let's go through this real quick. Hopefully we got through it in class and we'll make it work. All right, so when we do this, we're going to use the leading coefficient test, which is going to tell us our end behavior. We're going to find y-intercepts. We're going to find x-intercepts. We're going to find relative mins and maxes and additional points. All right. This is a little, I don't want to have to change around too much, but I guess I can if I need to. Let's see if we can make that work. All right, so what we're going to do all of these. All right, the first thing we need to do is talk about end behavior. All right, end behavior is what's going on at the end of the graph. So we have a positive x to the third. Going back earlier in the lesson, we said a positive x to the third is going to fall to the left and rise to the right. So we need to make sure that happens when we graph this. If it doesn't happen, we've got an issue. All right, the y-intercept. To find the y-intercept, we're going to plug a 0 into x and do our math. If I put a 0 into x, I get a y-intercept of 0, -2. All right, now the rest of it, for now, because we all don't have calculators, we're going to go to Desmos for now. We'll fix this later. We get this graph. All right, so what we're going to do, looking at this, we already said my y-intercept was -2. I'm okay with that. My x-intercepts are going to be these 3 points. So what I would do is I would graph these 5 points first. We've talked about relative minimums and maximums. The relative maximum is where my graph goes from increasing to decreasing, which is this point. 3 decimal places is what I want. That's just to be our standard. All right, down here on the bottom right, my graph is decreasing and changes to increasing. So that's going to be my relative minimum. Then lastly, it says we need additional points. We're going to find some point on this graph that we can easily graph. Let's go, what do we got? All right, 1 point, let's go 1.2, if I can get there. All right, that's an easy one to graph. I'd probably pick 1.2 because it's still close to what I need to be. So the idea is I need to find some point here and some point here, and we can call it, if you want to graph that one, that's fine too. All right. We just got to find some point. Just there we go, -2, -4, that's even better. All right, so what we're going to do is we're going to graph this in Desmos. My leading coefficient test says it falls to the left and rises to the right. I'm going to pick out my relative mins and maxes. My y-intercept we can do by hand, just plugging in 0. Our x-intercept's not always going to be as pretty, so we're going to go to the calculator. And these are the points in addition to some other point on the graph somewhere. All right? And that's going to give us enough. All right. Now we're going to find the function from the zeros. I'm going to tell you there's a function that has zeros at 5 and -3, and I want to know what that function is. So I'm looking for a function that has zeros at 5 and -3. So what we're going to do is we're going to write a factor. X minus 5, because we do the opposite. And x plus 3. And then last, we're going to FOIL. So you get x squared minus 2x plus 15. Because we know if I have a factor, we take out the solution as the opposite. So if I have the solution, I'm going to put it in as the opposite. All right, number 6. Same idea. I'm going to put in the opposite of this. and the opposite of this. So I'm going to do it like this. I'm going to do x minus 1 plus the square root of 5, because that's the opposite. And then I'm going to go x minus 1 plus the square root of 5. Oh, not plus the square root of 5, minus. That's the other one. Now I'm going to distribute. And get this. And I haven't even foiled yet. All right, but that's my idea. I put the opposite into my parentheses. Now my FOIL, I need to do x times all three. I need to do negative 1 times all three. And I need to do a negative square root of 5 times all three. So I'm going to go through that. X times x is x squared. X times negative 1 is a negative x. Plus x squared roots of 5. And hopefully, if I do this right, my square roots are going to disappear. Negative 1 times x is negative x. Negative 1 times negative 1 is a positive 1. Then minus the square root of 5. Then minus x squared roots of 5 plus square roots of 5. And a negative square roots of 5 times a positive square roots of 5 is a negative 5 itself. Because square root of 5 times square root of 5 is the square root of 25, which is 5. Now to clean this up, x squared minus 2x, those cancel, those cancel. I lost my plus 1 somewhere. Did I write plus 1? Yep, I lost this. All right, let's back up a step. Negative 1 times negative 1, so I have a plus 1 in here. Then lastly, 1 minus 5 is a negative 4. All right, so when I have 3 terms times 3 terms, I better get 9, and I made the mistake of lost 1. So I realized I only had 2 of those pink ones, so I had to put that plus 1 that I forgot. So the idea, given a solution, you do the opposite inside the parentheses. And that's what we're going to call it quits there. All right, so that should wrap up everything we need. All right, this is not your homework, so don't look at that. In the WebAssign book, or in the WebAssign program, you have an assignment. All right, finish it, submit it, you get 3 tries. After the first try, it should give you some hints, some tutoring options to help you out. After the third attempt, it's going to give you the answers. All right, this is not just something to fake your way through just to get credit. It's for you to learn it. All right, we need to make sure and need to start getting all of our work done on time. Too many people are taking advantage of our kindness of letting you turn in stuff late. It's going to stop. We have to do what we're supposed to do and do it on time. All right, we'll talk about that in class. All right, so we're going to wrap that up and have a great day.